Hello and welcome to another tutorial. So this time around we are taking another deep dive into classes. So we've previously done a little bit of a deep dive there where we took a look at things like interfaces and looking at areas like inheritance. Now this time around we're going to be taking a look at a few other things that we can be doing with classes and getting a bit more of an understanding there of the kinds of cool, interesting things that we can do there and some of the implications there for when we are working with them. So let's dive right on in. So I've created a really basic empty scene because there's going to be very little that's actually sort of happening here with this. So the first thing that I want to dive in and show you is we've seen stuff where we're working a lot with classes, and we've also potentially seen a mention of things called structs or structures. So I want to actually have a little bit of a look at what's different between those. So we're going to just start off with simple C# script that I'm going to call class verse struct. So we will use a mix of both of those in our code. That's quite common, and Unity does use a mix of ones there. So we've got our code set up and we'll just attach it onto the cube so that it's running. So I'm going to set up two simple things. One that's a simple class, the other that's going to be a simple structure, and we'll see how they behave differently. So I'm going to just keep these both public. So public class demo class and public struct demo struct. And I'm going to create a variable inside each one of these. Int value, I'll call this one. And then this one I will call the same thing. So these two are identically set up. The only difference is one is listed as a class, one is listed as a struct. So let's find out what actually is different with these. So let's firstly create demo class, and I'm going to call this DC1. So DC1, I need to, it's going to get grumpy at me because I'm not using it yet, but we'll notice I can't access int value. So that's one of the immediate things. Variables, if we don't set any access level, then with a class, by default, variables are going to be private. Let's see if the same is true for our struct. So demo struct ds1. So ds1 dot, and it's the same with that. So if you've come from C++, this might be something that actually seems a surprise, that is actually different. In C++, by default, the members there of a struct are actually public. In C#, they're actually not going to be. And yeah, we can confirm just to make sure that it's definitely, and we can see it is properly telling us that. And just, you know, if we were like, okay, maybe the IDE is lying to us, let's double check. Nope, it is definitely not correct, which is fine. So that's an initial thing we know. So far, not anything different between these two. Make that public. So now, okay, well, DC1 dot int value is equal to 5. DS1 int value is equal to 5. Now, this is interesting. This first one is getting cranky at us, but the struct one isn't. And if we come back here and again, so classes, we know we have to do this. They have to be initialized like that. We haven't done that with the struct. Does that mean it's going to work? So again, we can test it. So this is something I really encourage. Don't be afraid to write line of code and just run it and see what it's potentially going to do to test out the behavior. Unless you are doing something where it is directly working with the file system or things like that, you're not going to be able to break your computer. Obviously, if you were doing something that is working with the file system or system registry, anything where damage or deletion corruption could cause significant issues, be very cautious in that case. But outside of that, you're not going to cause any harm. The worst you might cause is you might have to end task Unity and restart it if you cause a really hard to exit out of infinite loop. So don't be afraid to dive in and test with stuff. So we'll just run this and we'll see. So it runs, seems like it's run happily. Let's log out the values just because that's going to be a good test for if it's working correctly. Debug log ds1 in value. And then we can run this. So we'll run it up. So seems like it's working, which is good. So there's another difference we've identified between classes and structs. The class, I had to initialize it, whereas with the struct, I didn't. So, okay, that's cool. Well, what if I want to give these an initial value? 42. And then if I turn off these, and I would hope to see values. Now this is interesting in that this is warning me, and it actually will not properly run it. So if we look at the error, cannot have field initialization. So this is valid in a class. It is not valid in a struct. Now we could test and see, okay, maybe what if I take a step further and do a new demo struct? Is that going to make it happy? And we can see the errors disappeared, except hasn't. The IDE error has disappeared, and this is something we do need to watch for, that the IDE in Unity will sometimes disagree. So this is not something that the IDE is warning about, but it is something that Unity is actually saying is not supported, is not valid. Now, this could be down to the C# version the editor's using. If we take a look in our project settings, and if we take a look at the API, so you'll see API compatibility level. By default, Unity still will default to .NET Standard 2.0. We can test and see if we change that to .NET 4, which will change some of the things that are supported, but even with that, it is still not something that is actually viable. So this is a restriction that we need to be aware of, that we cannot do this. And that although doing this makes it less grumpy about this aspect, it doesn't actually fix the problem. So, okay, well, what about the other way of constructing stuff? Can we have a constructor? Because we know with classes we can do that. Int value equals 42. And we'll do this for our demo class. Demo class, int value is equal to 42. So the IDE isn't complaining, but this is not supported for our demo struct. So another limitation there with structures. We're quite constrained with how we're setting these up. Now, it does, however, say they cannot contain explicit parameterless constructors. So what we might be able to do, initial value is equal to 42, and we do this. So it now has a constructor that has a parameter with a default value. So we're kind of doing a little bit of a cheat way around it. Will it allow that? So it's having to think about it a bit, but that compiles. So let's test if that runs and if that actually gives us the correct values. And we can see for our class, yes. For our struct, no. What if I actually put an explicit value here of 42? What happens then in that case? So we're specifically giving it a value. Now we're clear in terms of errors. Do we get the particular value come through correctly though? And we can see now we do. So even though we set a default value, it was actually not running that empty constructor. Having an empty constructor for a struct is not supported. It's something that is not allowed in C#. It will not actually run it. So even if it doesn't cause an error, it doesn't actually do anything. So with structs, we have to provide values there. With classes, we don't. So a few key differences we've identified. A class, we can have an empty constructor. We can also provide initial values where we declare the variables, and that will work. With a struct, we can't provide an initial value there for the variables. And while we can have a constructor, the constructor must, absolutely must, take parameters, and it will only be run providing those parameters are there. So that's a key important thing there with those. Final thing we want to take a look at is we set up DS1, DC1, these things here. So let's go demo class DC2 is equal to DC1, and then DC2 int value is equal to 500. And I'm going to do the exact same thing here. Demo struct DS2 is equal to DS1, and then DS2 int value is equal to 500. So this is going to tell us how these are behaving, and in particular it's going to tell us whether these are behaving by value or by reference. So we're going to run this, and we get 500 for the class version and 42 for the integer version. Sorry, for the struct version. So this is an important thing. Classes pass by reference. So when we do this, we are not creating a new copy. What we're doing is we're creating something that just links back to that original one. So whether we access DC2 or DC1, we're talking to the same chunk of data. It's a really important thing there. So classes pass by reference, which means they don't create a new copy. Structures, it did create a copy. We changed DS2, but that didn't change the original. So structs pass by value. They create copies. So these have important implications. If you have large amounts of data and you're having that contained in a struct, that means passing that around. So passing that into a function, things like of that, it's creating copies. That's a lot of extra memory that it's potentially using, and a lot of extra overhead for creating and managing those copies. So in terms of with structs, we generally only want to use them for very small, very simple sets of data. It's why you see structs used for things like a vector 3 or a vector 4 or a vector 2, something that's holding small amounts of simple numeric data. So structs are absolutely really, really useful. But keep in mind, you only want to be using them when the data that you've got is small, when the data that you've got is simple, and when it's okay for the behavior of working with that data to be that it creates a copy, that it doesn't refer back to the original. As soon as you've got large amounts of data or complex data, be using a class. And when we're talking large amounts of data, I'm talking more than sort of 3, 4 floating point numbers or integers. Anything more than that, you want to start thinking about using a class so that you can minimize duplicating the data. So that's the key stuff with classes versus structs. So now we're going to take a look a little bit further at, well, that's our cube doing that. We're going to look at something called an abstract class. So I'm going to create another script here, abstract classes. So abstract classes have a little bit of an overlap with interfaces. There's a similar sort of aspect there with that. So I'm going to just temporarily turn off the class first struct one so we can have our output coming through. So I'm going to run this. So I'm going to set up a couple of classes. I'm going to set up a fairly traditional setup in terms of inheritance. So public class, and this might be base character. And then let's have something that inherits from that. So it might be player character inherits from base character. So we've seen how with interfaces function as a way of essentially a contract of saying this thing that implements this interface must implement this particular function. And we did also see with interfaces, though, that the challenge they had was interfaces store functions, but you can't have a body for any of those functions. And you also can't store data there with that. So we might want to. So say we have stuff here where we're going to have a protected vector3 location. So we couldn't do this with an interface. Now, we might want to have stuff here in terms of, okay, well, we want to move function. So we could have a public virtual void move to new location, and I give the speed. So that's good. We can implement that, but then we're not forcing the other class here to actually have to implement that. Oops. So we're not forcing the player character to have to implement that. Now, there are things that we can do where we could in here put in a very noisy error message, stuff like that, something that says, okay, we're reporting a problem. But that's something that we then only catch it when our code runs, which is still valuable and still useful, but it means that we're catching the problem a lot later. It's not catching it in the moment of doing the development. So there's a bit of a delay there. It means it takes longer to track things down. What we can do is we can say that this function is abstract. We can also do stuff where we can make an entire class abstract, but how this looks is, okay, we can say abstract. And then what this means is this function. So we can see that we have to also then set this class. So abstract functions can only be within an abstract class. So an abstract class, you can't instantiate. If I tried to do, temp is equal to new base character, I can't instantiate it because it's abstract. I can only instantiate things that inherit from it. Again, really useful, because this now means this player character, my code won't compile until I implement that function. So that means I could set up public void move to vector3 new location float speed debug.log move to, and we'll put the new location at speed. Now it's still getting grumpy at me, and that's because, much like with our inheritance, I have to be telling it that I am overriding that function. So I have to actually say that this thing is being overridden. Now, that's really handy. That means that I've got a way of enforcing that this function must exist. But I can do this alongside. So if I could set up, public void, this might be a function that, let's call this teleport to. And we give it a new location. And maybe the teleport to is actually implemented. We can do that. Debug.log teleport to new location. So this is an advantage that, and a difference there with abstract classes versus interfaces. In an interface, we would not be able to do this. In an interface, we wouldn't be able to set up so that we've got a variable. We also wouldn't be able to have a mix of functions that are implemented and functions that are not. So this allows us to do that, which is really powerful. So abstract classes are really useful in that regard. The fact that I can't instantiate the base character and I have to instantiate this, really handy. So abstract classes and interfaces work well for different sort of purposes. Interfaces are great where you're just trying to enforce a pattern of how something looks, whereas an abstract class is good for if you've got some common data, some common functions, and you want to enforce that a child class implements a particular aspect. Abstract classes let you enforce that using that similar sort of logic that interfaces do, that similar sort of requirement of having to implement a particular functionality. Now, the main thing that's different there is we can still only inherit from one thing. So a player character can inherit from base character, but we couldn't inherit from multiple abstract classes. That's still not a supported thing there in C#. So interfaces still come in handy for cases like of that, where we've got, okay, well, there's going to be one base class that I do inherit from, and that one I'll make abstract. And then I'll say that I implement particular interfaces to enforce different functionality. And you see that a lot within Unity, where there's a lot of things that will inherit from stuff and they'll implement particular interfaces. If we go and just take a look at things like mono behavior. So mono behavior, we can see inherits from behavior. And if we go back a little bit with it, they're implementing things like components, so it goes back through all of that sort of process. If we go to something like transform, is a good example. Transform inherits from component, but it implements IEnumerable, allowing you to iterate over the contents of a transform. And this is where the core logic, the main things transform needs, are related to component, which is why it inherits from it. But it implements IEnumerable so that it will see there'll be specific interfaces that it has further down here, where it's having to provide these because it implements that IEnumerable interface. So really, really handy setup using that mix of abstract classes or just base classes and also interfaces. So in terms of where you should consider using abstract classes, it's similar with interfaces, but the main difference is if there is common data, if there is common code that you want all of the child classes to have, an abstract base class can be really valuable there because it lets you enforce those rules of what things can be implemented. And one little thing that I'll show you with this that can be really handy and is a pattern that I often follow with classes is I'll actually have something where, let's say, I want to have a function where it's not just moving to, maybe it has like a navigate to function. So navigate to vector 3, new location. Then, so that's not an abstract one yet, but then what I could do is I could have, there might be some common setup goes here, might be some common cleanup code goes here, and then here I do navigate to internal vector, and I pass it that new location. And then what I do is I set up now it becomes protected. So we have a layer of functions that are not accessible outside of this class, but we have a public interface that is. So we can do a little bit of cleanup and logic either side, which can be really handy. So this is a pattern I use in a lot of ones. So navigate to internal, vector 3, new location, and I'm going to make that abstract. What that means then is we have to have protected override void navigate to, and we won't throw the exception there. But this allows you to wrap some common code. So it means that you can ensure that a child class does a particular bit of logic at a particular point, that certain setup and things like that happen. And it allows you to do that while still presenting a nice, clean public interface that everything has to go through. And then the actual low-level implementation logic is handled internally, and those functions are not accessible. So this can be a great way of shielding that internal logic and enforcing a bit of a better sort of control of the flow of what things people are accessing with your classes. So this is a pattern I follow a lot with when I'm working with base classes. I find it works really effectively for creating nice clean interfaces and ensuring that the child classes are properly implementing all of the particular functions that we need. So that's abstract classes. Similar to interfaces, but allows us to have additional data and logic while still enforcing the rules of things existing. One final thing I want to take a look at, and that's something called a sealed class or function. And what I'm going to do is I'm going to set up sealed classes. And we will attach that to our cube as well. And we'll see what a sealed class looks like. And there are classes already in Unity and in C# that are sealed. So public class demo sealed class, and we'll just leave it at that. So I can mark this as sealed. Now, sealed has a very specific meaning, and what it means is you can't inherit from this. If I try public class demo inherited class from demo sealed class, it immediately tells me, nope, can't do that. So sealed can be a really useful thing when you have a class where it's a case of it is not safe to inherit from this. This class needs to be completely standalone, never anything overridden. It is not designed for that. You can mark it as sealed. So this is one example. As well as being able to seal an entire class, which means we can't inherit from it, which also means a sealed class can't be an abstract class, because abstract ones we can't instantiate, and sealed we can't inherit from, which means if we had something that was abstract and sealed, we would have a class that we could not instantiate it itself, and we could not inherit from it, which means it would essentially be useless. So we don't want to do that. We can also, if we take a look, so I'm going to set up demo class, demo base class, public virtual void demo function. Now we used to, okay, I can do public class demo child class that inherits from demo base class. And we can do public override void demo function. So we're used to being able to do that. And I could have another one that inherits from that again. So demo grandchild class that inherits from demo child class. And I would be able to go again, public override demo function. So I can chain through that overriding. But say this class here, if that function, I had decided it was not safe for that to be overridden, I can actually prevent that. So if I say seal, you'll notice immediately I can't then inherit from it. So sealed is a way essentially of blocking inheritance. We can block it at a overall class level, if that's appropriate, or we can block it at an individual function level once we've overridden it. So we've substituted in our own version for a function. We might say, yep, this function, anything based off of this, it is not safe for anything to override it, so I will prevent it. So sealed is a thing that it's about ensuring sort of quality and security of your code. It's a way of writing and structuring your code so that it's harder to have problems occur. And that's what a lot of this stuff's about, is finding ways to make it, not that you can't create problems, but that it's harder to, that we're less likely to run into errors. So sealed is really great for stuff like of that. We're setting our intent that this is not safe to be overridden. So it can be really useful in cases like of that. I don't find I often have a huge need for it, but if I'm writing more of a library style thing, so something that I'm intending being used in a lot of different projects that a lot of other people are using, that's something where I would be making a lot more use of things like abstract and sealed to enforce and ensure the behavior there that we're going for. So, okay, we've seen class versus struct. We've seen abstract classes, we've seen sealed classes. There is one final thing that I want to take a look at, and that is something called a static class, which we have used static classes and functions before, but we're going to take a bit more of a look. So we're going to link this up. The cube is attaching a lot of classes to it, which is cool. So, okay, we've seen normal classes where to use them we have to do new and then the class. The idea behind a static class, or even just a static function in a class, is that we don't need to do that. So if I have public static class and demo static class. So this gives me something where this entire class is static. So I never actually go and new this class. So writing something like new demo static class is not something that I would do. And it will actually give me an error that I can't create an instance of it. It's because creating an instance of it is not a supported thing. We don't do that with a static class. And what I can do then is, in terms of functions, well, okay, if I set up a test function, and you can see it's immediately cranky at me because, well, I can't create an instance of this, but this function I'm saying belongs to an instance. So I have to actually mark this function as static because it's not valid for that function to exist otherwise. And so this gives me the ability to do stuff like, I'm going to demo static class, test function. So this is really handy for when you've got a lot of utility things that you need to do. For example, if we took a look at mathf and go mathf.min, if we go and take a look, it's a static function, and we go right up to the top. In this case, it's a struct, whether it's a class or a struct. Doesn't make too much of a difference there in this case, but we've got a struct that has those functions within it. This could also be a static one as well. But so having these static functions is really handy like of that. We can have data typically here as well. So again, public static int, and this might be something like max health. It's equal to 500. And we could then refer to that from anywhere. Could go, okay, debug log, demo static class dot max health. We could change that value. So it gives us stuff that can be stored in a central location. We can access quickly, easily from a lot of areas. It's really handy, really powerful sort of setup there. We can also just have static functions within a particular existing class. So public class, this is going to be demo of a static function. So this is now a class that we can instantiate, but I'm going to give it a static void test function. So this, actually, I'm going to call the, yeah, no, that's fine. One of the things that you can do is you can also have, and this is not an uncommon thing, of having a static function that creates an instance of that class. So that, which I'll demo what that looks like. Public static demo static function, create, turn new demo static function. So this is a common pattern that you will see in some cases where you control and manage the creation of that class fully within that particular class. So it can be really handy because what we can then now do is, okay, var DSF, we can go demo static function dot create. We could also, then we'll see if we go DSF, we can't access any of these static ones because we're working with an instance. So that's pretty cool. We also, so this is DSF1, we do DSF2 is equal to new demo static function. That currently works, but if I go private demo static function, then now it doesn't. So we can use static functions to make it, and also having a private constructor. This allows us to make it that the only way that you can create that particular class is through the class itself. That can be a really handy thing where it's a case of you've got very specific setup processes that need to happen and very particular things that you need to ensure happen during that construction process. By forcing it that the construction happens within the class itself, it allows you to control and manage that process better. Because it prevents us creating it via anything other than the interfaces that it has, which is really, really powerful. So just to recap on a bunch of the things we've looked at, because it covers a wide range of areas. So we had a bit of a look at classes versus structs and seeing how they behave differently and the kinds of things we can do with those and some of the things that we can't do with them. Some of the main differences being there that classes pass by reference, so it doesn't create copy, whereas structs pass by value. So it means we want to use structs only for small, simple data. We also saw that for structs, we can have a constructor, but that constructor must take parameters. It can't have a parameterless constructor. It can't have default initialized values. So that's the key thing we saw there that's different with those. We saw abstract classes that are like interfaces, except they store data. We can implement some of the functions and we can use that to enforce that child classes have to implement a particular function, similar to what happens with our interfaces. We also, by making a class abstract, we prevent that being instantiated, which can be really handy for base classes where that might not be safe to do. We saw using sealed classes as a way of saying, nope, this class or this function cannot be inherited from. So a way of enforcing some rules there in terms of how those classes are interacted with and worked with. And then finally, static classes and functions as a way to set up utility classes that just hold a bunch of useful functions, or to have the pattern that we used of bringing the creation, the construction of a class, so that it has to happen within the class itself via specific interfaces. So all of these are about different ways of enforcing different sort of rules and processes for how our code works, with the goal being to make more robust, more reliable code so that we don't run into problems. It's about defensive programming, essentially, so that you're trying to avoid problems happening by making it that any issues get flagged really early and the compiler works on our side and flags those things as being a problem. So really valuable for ensuring that code quality so we get less bugs. So I hope you found the video helpful. If you're looking for the code for the project, then the code is available up on GitHub and the link to that's in the description below. You can use that code in any of your own projects, whether those are commercial or non-commercial, so dive in and make use of it. If you've got any questions, chuck in a comment below. And if you have found the video helpful, please do chuck in a like and subscribe. It really does help out the channel. And if you're looking for other ways to support the channel, I do have a Patreon and the link to that's in the description below. Bye.